everybody, today we're going to find the derivative of f of x is 9 over x using the four-step definition of derivative method. Once we find the derivative, we'll also find f prime of 1 and f prime of negative 3. The first step is always finding f of x plus h. In this case, that'll be 9 over x plus h. I just put in x plus h wherever I saw x in my original function. Next, I subtract f of x. This gives me 9 over x plus h minus 9 over x. In step 3, I just divide by h. When I do that, I form a complex fraction. I have a fraction within a fraction. I have 9 over x plus h minus 9 over x in my numerator, and then h in my denominator. What we're thinking about is getting to step 4, where we find the limit as h goes to 0. So a little bit, I'm thinking right now that I have a 0 in my denominator, and I'd really like to get rid of it. So before I get to step 4, let's see if I can make this fraction look a little bit better. To start out, I'm going to try to clear the fractions in the numerator. To do that, I'm going to multiply by x plus h times x over x plus h times x. This is just a version of the number 1 because I have the same thing in the numerator and denominator. I'm going to distribute the x plus h times x to each of my 3 pieces. That looks like 9 over x plus h times x plus h times x minus 9 over x times x plus h times x over h times x plus h times x. Now let's cancel any of the factors that we can. I can cancel an x plus h times x plus h in my first term. Then I can cancel x and x in my second term. Now I have 9 over x minus 9 times x plus h over h times x plus h times x. We're going to stick to simplifying the numerator and we're leaving the denominator alone. We will not be expanding that at any point. Let's distribute negative 9 to our x plus h. That looks like 9x minus 9x minus 9h over h times x plus h times x. Let's cancel out the 9x's to give us negative 9h over h times x plus h times x. We have one more step we want to do before we head over to step number 4, and that is to cancel our h's. This is a crucial step because it gets rid of our factor of 0 in the denominator. So the h's cancel out. I now have negative 9 over x plus h times x. We'll grab this and we'll put this into step 4, which is using the limit as h goes to 0. Because we've gotten rid of that factor of 0, I can just plug in the number 0 where I see h. I have negative 9 over x plus 0 times 0, which simplifies to negative 9 over x squared. Notice that when I put in the number 0, I don't write the word limit anymore. Using the quantity of 0 replaces the need to write the limit. Now that I have my derivative as negative 9 over x squared, I can evaluate it at the numbers 1 and negative 3. F prime of 1 is negative 9 over 1 squared, which reduces to just negative 9. When I find f prime of negative 3, I get negative 9 over negative 3 squared, which becomes negative 9 over 9, or negative 1. This shows us that the value of the derivative changes with the value of x.